Welcome to learners. We have seen first three sections, which is related to brain-computer interface. Uh, basically, basically it will be introduction to BCI, EEG signals, basics, and third one is the EEG signal pre-processing. Now, section 4 is the furthermore step of pre-processing stage, and the next stage of pre-processing, which is feature extraction and classification. They are the two steps afterwards of the pre-processing. So we will start the lecture and we will learn something about feature extraction and classification in machine learning concepts. So what is the learning object is to extract meaningful features and classify the EEG signals. So extracting the features, and that is feature extraction, and then we will go for a classification of EEG signals. So in this lecture we will see what is the feature extraction techniques and what are that majorly we look at the power spectral density PSG and common spatial patterns CSP. So what is the power spectral density is? It will measures the power signal across the frequency bands. So different frequency band, how the power will be varies. That will be power spectral density. So it is the one of the feature we will see. It is the statistical features which will be used for the purpose of the feature extraction and as well as the classification of these brain signals or brain rhythms or brain waves or EEG signals. And what are the common spatial patterns? These are the patterns which will extract the features that differentiate the different brain states. So what are the brain state? How the intensity of the brain activity will be there, that will be indicated by these common spatial patterns. It is the majorly used in the brain computer interface for the feature extraction, because it is the major used technique in a BCI, so that we will easily identify the different features and also accurately we can classify the different patterns, so that what will happen, the accuracy will be increases and the application oriented also fruitful. And what are these techniques which will be enhance the classification accuracy with the EEG based BCI systems. And what are the introduction to machine learning for BCI is what are the algorithms, machine learning algorithms are essential for pattern recognition in EEG signals is there is a supervised learning techniques are there. Majorly we will see that LDA technique, SVM technique and decision tree, they are the major techniques we will use in the supervised learning ML algorithms for the feature extraction purpose. So what are the LDA means? Linear discriminant analysis and support vector machines and decision trees. They are the three techniques used for the feature extraction technique, and we will mostly use SVM or LDA because they are the non-linear classification is also plausible, and which will what are the data sets or data needs to be proposed or given to this algorithm and extract the features before classification. So you will go for a classification when you have to compulsorily you go for a pre-processing as well as the feature extraction. So in the pre-processing we already seen different filtering techniques, and now this is the feature extraction techniques who are used SVM and LDA and decision trees. So how to implement this CSP algorithm with LDA or SVM classifier is, so we can see this apply the CSP feature extraction technique to multiple channel EEG data. Then you have to train the linear discriminant analysis LDA classifier or support vector machine classifier. Then evaluate the performance using this testing data. So whatever there feature extraction output you have to given to the to train the classifier SVM or LDA and evaluate the performance of using a just test data. Then how to evaluate the classifier performance is you have to use the confusion matrix. The output of a classifier anything is a confusion matrix not to measure the accuracy and the precision and the recall. And also you can plot the ROC curve to visualize the performance of that classifier and evaluate the overfitting and underfitting using cross validation techniques. So what is the overfitting and underfitting is whether the test classifier is capable of the data will be is there not that will estimate by overfitting or underfitting. The classifier is the should be optimized or output should be optimized because it should not be overfitting or underfitting. And what is the assignment you given for this uh, lecture or the section 4 is EEG signal classification. So how to use the pre-post data, EEG data, and apply how to use CSP for feature extraction, how to train the classifier LDA or SVM, and how to evaluate the accuracy using the confusion matrix, and how to also how to submit a report with analysis and plots. So this is the assignment given to the this lecture. You have to go through this lecture and you have to find out what is the possibilities of getting this idea and apply these techniques and you submit the report. And what is the quiz for the feature extraction and classification is what is TSP stand for EEG pre-processing signal is signal processing is common spatial pattern. And what is the advantage of using SVM over LDA is SVM can handle non-linearly separable data better than LDA. And what is the confusion matrix is to evaluate the performance of a classifier by showing a true versus predicted values or classifier values. And define what is the power spectral density. PSD is represent the power of the signal distributed over frequency, indicating how power varies with the frequency. What does the ROC curve represent in a classification means? It shows the trade-off between the true positive rate and a false positive rate at various threshold settings. So this is the classification, the feature extraction after the pre-processing technique. Okay, so thank you very much. So we will see in the next lecture 6.